brief calculus students, I'd like to go over the chain rule for derivatives with you. Unlike the other videos on YouTube, this one doesn't have trig functions. And it's basically, you have a function that's the whole function is being raised to a power, in which case you just use the power rule, the n times the function times, raised to the n minus 1 power times the derivative of the function. Or if you have a function inside a function, then you take the derivative of the outside piece, keeping the inside the same, and then you take the derivative of the inside. So I'm basically going to concentrate on a function of a function. Let's say we have a function that says take what you have and raise it to the 4th power. And you have another function that says 3x squared plus x, that's your function. I used u because we're going to be using u again with integration. We call it u substitution. That's why you see it. So basically what we're doing then is saying, okay, we've got something that we're going to raise to the 4th power. We just stick with that something is. So this is how we say it's a composite. It's a function of a function. And when we take its derivative, we take the outside function derivative, keeping the inside the same, and then multiply it by the derivative of the inside function. So if we look at the first function, it was u to the 4th. So when we take its derivative, it's 4u to the 3rd. And then if we look at the second function, or the inside function, derivative of 3x squared plus x is 6x plus 1. So when we try to take the function and then stick the inside in, times the derivative of the inside. So I know I'm going to have 4 times this quantity raised to the 3rd power. It's just going to be that g function. And then I multiply it by g prime. Fill it in. This is a great answer. I'm happy. I don't expect you to try to multiply stuff out 3 times. It's great. So here's another function. We have the square root of something. And then we have 13x plus 1. It's a basic linear function. So if we want f of g of x, we just stick that 13x squared, or 13x plus 1 inside the square root. So when you take the derivative, well, first of all, f prime will be 1/2, because that's what square root is a 1/2 power. So we move the 1/2 down, u, and then 1/2 minus 1 is negative 1/2. We take 13x plus 1, we want the derivative of that, it's just 13. So we have the f prime of g times g prime, and I left off the prime symbol. I saw that when I was trying to trim down all the functions. I went, oh no! But you can see when I fill in the blanks. So this one is going to be the straight function of g, and then this one's going to be the derivative function. So I fill it in, so there's g, and then there's g prime. And I drew a little arrow so you can see. And then I said, if you really want to, you can simplify, but that is not necessary. So I'm sorry about the prime. Okay, new function. Move this over a little bit. I took this because it doesn't necessarily tell you what the outside and inside functions are. So right here, the clue is what's inside the parentheses. Well, we call what's inside the parentheses g, which simplifies the function down to 3g squared plus 5g cubed, and then g is just 4x plus 1. So we look at the derivatives. We've got 60 plus 15g squared, and g prime is 4. So when we take its derivative, outside function with inside remain the same. And then I forgot that prime again. Yes, there we go. I stuck it in, retook the pictures. So, and then I had to, yeah. So f prime was 6g plus 15g squared. So I'm going to have to stick that g in for all the g's. Then g prime was 4, so just multiply by 4. And I just round room. Okay. So 6 times 4x plus 4 plus 15 times the quantity 4x plus 4 squared. I closed that in parentheses and said times 4. If you really want to move the 4 in front, that's fine. This is a great answer. Okay, new function. 1 over x squared plus x cubed. Doesn't look like it should be an inside-outside function, but why don't we just go ahead and let what's on the bottom in the denominator be the inside function. Then, if it's equal to g, then we can say the h function is 1 over g. And g can be x squared plus 3x. Now I'm starting to move in a sort of a new notation. Well, first of all, 1 over g is the same as g to the negative 1. So when I take its derivative, you can see it's negative 1 g to the negative 2 power. And then g prime, of course, is 2x plus 3x squared. So when I want to take its derivative, I actually wrote it down in a different way as just the, that should be a g right there, I'm sorry. Negative 1 g to negative 2, but I knew g was a function, so it needs to be multiplied by the prime, by the derivative of the function. And then I can just fill in g and g prime, and since it's a negative 2, I can move it to the bottom and make it positive 2. So x squared plus x cubed, quantity squared, is going to be on the bottom, and then that derivative, or the original, derivative of the original function is up there on the top. This is going to be very, very useful when we get to integration. Okay, this question is useful because we actually use the chain rule twice. And again, I took the shortcut of saying, okay, let me just call this function right here g. So 2t plus 1. And then this will simplify down to 3g squared plus 5 quantity cubed. Well, this is still an outside function, inside function, so why don't I call this inside h. So h would be 3g squared plus 5, and that would leave the original function as just h cubed, which is easy to take the derivative, right? So s prime would be 3h squared plus h prime, because I know h is a function and it's not the variable I'm looking for, so I'm not done. So I have to go up to h and find its derivative. I know I can stick that in, but I still need its derivative. So it looks like 6g times g prime. So let me look at this. So what is the derivative of this function? It's 6g, but I know g is a function, so I have to have the derivative of the function g. So I can plug and chug. Now it looks like 3 times 3g squared plus 5 quantity squared times 6g times g prime. So I need to have g prime. And as soon as I get there, I'll have the original variable of t. So I need to throw in g, need to throw in 2. It looks like g prime is 2. Okay, so the function simplifies to 3 times, and then 3 times that function, g squared plus 5 squared, times 6 times the g function times 2, which is fine and dandy with me if you leave it like that. If you really want to simplify it, only multiply those numbers. I would keep the rest of it the same. And I need to show you a really cool website. Okay, so the website is www.derivative-calculator.net. And I'm going to put the function we just had in there. 3 times, and I'm going to use x, because see down here it's taking the derivative. Okay, squared plus 5 raised to the 3rd power. Let's see. Does that look about right? Yeah, 3x squared plus 2x plus 5 cubed. And I can say go. Please wait, calculating. So there's your input, and here's the output. And you notice the 36, and then they move the smaller piece in front, but there's the rest. Oops, right there. So here's the same answer, they just moved that small piece in front. Okay, last one, example 4 from your book. It's a big long one about profit. Depending on the number that you sell, the number that you sell depend on the number who are actually working on the line. So we'll have a function that needs to tuck in to the original function. So what I just did is say, alright, I'm going to take the derivative of p. And I know that q is a function, so I need to know. I got done, and then I said, alright, what is the derivative of q prime? So I put it in, figure, derivative of 100n is just n. So I stuck those in, and I got this answer. And by the time you multiply the 100 through and square the 100 right here, you get this answer in your book. And it's here where I realized, wait a minute, the book says 92. So I went back, oh, look, I multiplied 2 times 46 and I got 96. No, it's supposed to be 92, so I changed that to 92, 9,200. And so basically this is going to be kind of an upside down quadratic equation. Time for the calculator. So I put the function in 1, 2, 3. So here's the calculator. I changed the window so it started at 400,000, or went up to 400,000. I graphed it. Looks like this. I'd really like to find out where it equals 0. So what if I change the x to 100? So 100 people working on making these. Ooh, right here, very important point. This is where the profit stops moving in an upward direction. And I know it looks like it's going down, but it's still in the positive. Window, so let's say, so starting at 0, let's say, no, I need it negative. Negative 100,000 graph. So now we can see it. So a marginal profit that is in the first quadrant is a positive profit. When it reaches this point right here is where it stops being going in a positive direction. The profit starts decreasing. You're getting less and less. So this point right here is going to be very important. So second calc, where's my 0, 2? Is this my function? Yeah. Now I have to make sure that I have crossed the line, because it bounces back and forth in an echo, like an echo chamber. So if it doesn't cross the line, it will give you an error message. Okay, so we have about 30, maybe 38, 39 workers. We will have the maximum profit for this equation. Alright, there you go.